Slacker. That's excellent, Gus. I haven't tried beating the game at level 50. Why fucking repeatedly get beat down trying to do it as low level as possible when I could fucking run in there and just cleave the shit out of someone and take their head off. Much more fun. All right. So we got stuck last time. Our code wasn't working. Right as soon as most of you walked out, I was pasting the code here. And as I was typing, I was saying we're having a fault in the binary search tree constructor. I realized what it was. I wasn't using the node constructor. So if you look in our new thing, my binary search tree constructor, last time we were saying root dot data or root dot value or whatever was something. We didn't have root as a new node yet. So root hadn't been instantiated yet, and I was trying to assign it something. Well, previously it had said root dot set value. That's what we had done. We had done root set value arg, and we didn't have a node created in root yet, so root was empty. So that was the problem. It was like trying to use nodes set value, but there was no node. So if you change the constructor to root equals new node dot arg, not dot arg or argon as the argument, it will work fine. So what else do we want to do today? I had little notes I had to, we wanted to do more, add people to it. So let's make sure we made a comparator, and I see compare age. We haven't turned on the compare thing yet. So let's turn on the compare thing. And let's test adding a new person, because adding a new person definitely had the comparator in it, compare peeps. So hopefully this should add it, and it should add Barry Allen before David Jones, because remember we're doing by last name and first name. So it ran. Let's move the print tree. Let's put that at the bottom. That way I don't need to keep moving it. So it says Barry Allen's first. David Jones is next. And I don't like the way that's doing. We need a return in there. So this was on print in our search trees. So what does print look like? Where is there it is. I need an end line here. That looks tacky the way it is. And it looked like there was a lot of space between them, so I might just label that last C out and see how this works. Still a lot of spaces there. That's too many spaces. So that's got to be in our report. So let's go find root report or node report. It just looks a little tacky. It might have an end line here and then an end line in the report for node. I wonder if that's it. Where's node report? We actually already had. I'm gonna just comment out that C out end line for node report. See how it looks. Not bad. There we go. Okay, I kind of like that. I think maybe there should be a comma after the name. I don't know. Let's go up to display, make it look a little bit better. Get last name, comma. There we go. That's all it needed. Maybe we'll put a comma there. How's this look? Displays everything. If it looks like shit, you're like, I don't want to use this app. Whoever made this doesn't know what the fuck they're doing because they couldn't take the time to make it look decent. All right. Nope. Don't need a space after that. That looks funny. All right. So let's get rid of that space right there and that space right there. All right. That's looking pretty good. Now we want to test the comparator and make the tree kind of big. I was adding other people in it. I added several other Joneses. Let me uncomment these. Several other Joneses, another David Jones that was just younger to make sure that it did the age thing right. Then we got a James Earl Jones and Anita Jones. We have another Allen here at school. Let's add a Dylan Allen here. Let's throw it down here at the bottom. Dylan Allen. Dill Pickle Allen. Right? Yeah, we can do it in quotes. Let's do Dylan in quotes, Dill Pickle Allen. It's a good reminder of how to put quotes into a string. You got to have that, you know. Is that the fucking backslash or the forward slash? I don't know what that fucking slash is called. It's a slash. Oh, Juan, you showed up. Good to see you. All right. So it did put Dylan after Barry. It's got the Joneses in order, and it put the 25-year-old before David. And then James Earl Jones after David. So our comparator is working pretty good. Looks like everybody's in alphabetical order. Oh, we didn't check sorting by gender. So maybe this is going to sound funny, but let's maybe make this David Jones here a female. A confused fucking parent. Like that Boy Named Sue. Y'all heard that song, Boy Named Sue? That's really fucking old. So I had this, today is my 20th anniversary. And I was like, you know, I was giving my wife a kiss and I was thinking about it and I go, I've been fucking married to you longer than half my students have been alive. That made me feel really fucking old. Yeah, it is pretty cool. 20 years is a long fucking time. Let's see. I don't remember if we put females before males. I think it goes in numerical order. So David Jones, the female version should be before. And it is female versus male. Okay, I gotta change it back. This is just bothering me. All right. So let's make that back to 1 in the 25. What else do we want to look at here? Max, what did you email me about? What was the question? I know I answered it, but I think it was a good. Right, finding the size of the program. So it's lab B. Let's go take a look at lab B. Maybe we can incorporate those results here, like figure out what we want to do for it. All the way down. Ah, the worksheet. Okay. Minimum height. Okay. So real quick, how minimum height works. Actually, let me make that full screen again. And I'll make this search tree real quick as is. I want that annotate thing. There we go. So we start off with J, then N is to the right alphabetically, B is to the left alphabetically, then A would be to the left. A would be to the left of B. W would be to the right of N. E would be to the right of B. And then T is to the left of W. So this thing has a height of 1. They consider that 0, 1. And these are that's a 1 also. A and E are both at 2, as is W. And T is at 3. Now, if I went through and I did the same tree alphabetically, I would have A. That didn't change the fucking color. There we go. I would have had A, and then B is to the right, and then E is to the right, and then J, and then N, and then T, and then W. So this tree is all going one direction. We never went left. This has a height of 1, 2, 3, 4, 5, 6, 7. There's 7 W's at depth 6. So the idea is to make it search as quick as possible. You want this thing evenly balanced. Finding T is going to happen quicker here than it will over here. Does that make sense? So we want trees evenly balanced. So maybe let's find a way to make it evenly balanced. Eli's fucking stroking out. What? Yeah, like searching for it is less efficient on this one than it is over here. Okay. Where's the fucking clear all? Nope. There. Oh. And now we'll turn off annotate. Okay, so let's go back and look at our code and think about how could we do this? We've got person there, we got node here. This would have to be in search tree. Can we make a method that balances out the tree? Any ideas? Go for it, Juan. Yeah, but we're gonna definitely gonna need to do that. You're right. We're gonna need some sort of sorting algorithm that finds which one's the middle, because that's the, if we look at an ideal way of doing this, let me get the visualizer up. I think doing this on paper is a little bit easier than trying to deal with that annotator bullshit. Let's get visualizer up and running. And I need to spin it. And I need to change the resolution so it looks good. And I need to tell it to go into focus. So like, and I think that what I sent Max was a good example. Let's say we have an algorithm that's, or like a list of numbers that's 1, 2, 3, 4, 5, 6, 7. And doing them in order clearly is bad. Makes the long way.
I have a suggestion.
Okay.
Okay, well, we can kind of do what we already do. Oh, so you're doing, yeah, we can already do what we can use like one of the methods we already know for like a binary search and just apply it to that. So go down the middle, have a high and a low. The high is one right before the end because the end is a null pointer, and then you half it every single time. So you go from 1 to 7, then half of it is going to be should be 4, and then it's gonna have like it's gonna be able to tell if the next number is higher or
So
lower
split it, do the
than
midpoint,
if the number it's at is, yeah,
and
yeah.
then we can go to the left, do the midpoint again.
And then or the right,
Or
depending
yeah,
on
but eventually we're gonna have to
whether
do
the
both.
target or whether whatever, yeah. Yeah, yeah, exactly.
Eventually we're gonna have to do both. And then
Yeah.
maybe I'll make this a little bit longer. Let's make this up to 13. So the midpoint here is 7. That's our midpoint. And so the midpoint from next on the left side, that cuts it in half. This is midpoint number 2 there. And well, is it? It's between 3 and 4 is the midpoint. And between 10 and 11 is the midpoint here. So we have some arbitrary decisions we can make there. Because when it's this way, it doesn't matter which way we go, it's going to be the same length if we do it right. So let's say
Yeah.
we always round down.
Okay.
So we'll make it choose 3, we'll make it choose 10. This is doing 3, this is doing 10. Then we go midpoint again, number 3 goes here, which turns it to the left and goes 1. So I'm going to circle them as I do them. And then it doesn't have any more midpoints, so it comes back and does the 2. And we come back. That's wrong. There we go. And then it comes back to the 3 and goes, we're between the 7 and 3. This will be our next midpoint. We'll call it 4. So that's sending a 5 here. And then it goes next over here and here. We'll have a 4 and we'll have a 6. We can see that this pattern is going to minimize it each time we're cutting in half. But this requires having the numbers in order, right? Like when I entered the names, they weren't in order. This list could very well have been 10, 1, 2, 3, 7, you know. So like we could have had all those numbers here and not had them in order. So maybe we need to get all the entries. So get all the entries, sort them. Then do like a midpoint approach to balance the tree. Right?
Yeah. Because in order to do what we're gonna do, we need to have them sorted.
Yeah, we were assuming C. That's where we were doing midpoint approach to balance the tree. So we were starting with C, but that was starting with the sorted list. We don't have a sorted list. So we got to make that happen. So how could we do that easiest? Any ideas? One.
I mean, you.
One. Go, Eli. Is that you?
I mean, you obviously you don't want to go from node to node because that would suck. That's like a really long time. Uh, a better way to sort it would probably be. I mean, couldn't you do the exact same thing
What
where
do you mean?
you start where you like okay, so you do like a target type of thing. So you have say we start at like I don't know, we start at 1 or something, and if the value that we get is greater than 1, then it goes to one side, and if it's less than, it goes to this side, and we sort it that way. So we have like a list, and then we have it sort through the list, and then it puts the values that are less than that given value on one side, and the values that are greater on the other side.
So we need a list. That's the first thing we need, right?
Yeah, yeah,
A list or like maybe a vector. A vector we can do at runtime. We can add to it. We can cycle through the
true.
entire tree, throw all the entries into the tree, into the vector, and then we could sort fairly easily there. What? I'm sure, well, yeah, but we're like, what if we're doing objects like person? So we can't necessarily rely on that.
Do you want to do an iterator?
If you use a what? Okay, so someone walk me through what we're doing here. Eli. Let's include vector. I think we're making this a little bit harder than it needs to be. Or let's go look at, well, let's be smart about this. Let's go look at vector and list in the C++ guide and go, which one has the best sort? Because can we install a sort in it? So vector has a sort in it.
It does. You could probably use a for loop to kind of go through it with the sort.
But this is using
Like tree.
This is using integers. So like
Right.
let's look up sorting a vector with non-basic objects. Actually, sort with objects, classes. Then I'll add the word vector here. So vector has it. So first iterator, last iterator, comparison function. Okay. So like they have a my class. They just use integers again. That's not fucking helpful. Right. And then they didn't show the comparator. They didn't actually put a comparator in. Let's give it a try. Let's look up to see if list is any easier. So I'll open that in a new window, change my search to just make it a list. Fuck that. Hello. My computer's fucking.
Something I see that they're doing on Stack Overflow is that they're using like a key, like they're creating an actual structure for it. I don't think that's what we want.
All right, let's try doing the vector thing. So we'll make a method where we're down in our binary search tree. I included vector. You're gonna have to do that. Make sure you do that. So we'll say void balance tree. Void. And that's what we're gonna call it. So let's go to the bottom and start creating this thing based on what we were talking about. Scope it out. I think the node report has a good way of creating that vector. So let's create we want a vector persons, right? We'll call it temp. It does a recursive approach. And I don't want to do a recursive approach. But maybe we kind of have to. That's what I was thinking. Have two functions. Let's do that. So let's make another one. Oh shit, I'm gonna copy this right here and change the name, sort tree. We'll do the sort tree first. And I'm gonna go up and I gotta put it up top. Is that any better? Because once we've got it sorted, yeah, we may just want it sorted, not balanced. But that doesn't seem likely. All right, how do we want to do the sort tree? Still need a vector. My question is maybe we need to pass in a vector to do that. You know what I mean? Right, how do we create a vector recursively? Is that now that's what we're going with. You know what I mean? Which is fine. Maybe we can go with make this a vector, returns a vector person, takes in a vector person. Nope. I don't know. How do we want to do this? If it takes in the vector, all we got it, we won't need it here. So let's have it take in a vector. And we'll call this arg. Right, and we could push back. This looks like report was under node though, which means we're gonna have to do. Maybe this is better as a node thing. You guys want to try the sort tree as a node? Nope, it's called tree. We can do sort nodes, but that's again, that's assuming that. Fuck it. We're not stuck with anything. Let's call it sort node. And I changed a lot in this implementation name. So let's copy and paste this, put it up top. All the way up. And it's got to go in the node. Put it in here. And I'm going to get rid of sort tree here. And it doesn't like that because I don't need to scope it here. All right, let's come back down. So we've changed the name here. That's got to be sort node. So maybe this should be in brackets. So we can do a couple things because we need to push back, not just report. And it's got to take in arg. I don't know if that's helping. Because every time it's passing, we can't pass it arg. We gotta. Well, how? Let's do it. Let's do it. You're right. Doing it iteratively might be better. So maybe let's comment that out. So we've got some vector here. It's empty. And we start with our root. We're assuming that this starts at root. Is root, because we generally do root report. So maybe we'll say node pointer temp equals root. What? Oh, you're right. I don't know that I need to make it a vector person either. All I need to do is return the vector person. What do you think, Juan? You're the one that wanted to go iterator or iteratively.
You could say instead of using node test, you can go back to the binary tree class, call out. Afterwards, you can just say wow. So that is left the top node.
So go back to search tree or sort tree. Yeah. And we're not taking an argument. All right, let's go back up and let's change our fucking prototype again. This is how fucking coding works. You don't like, you're going down the road and you're like, nope, this shit kind of sucks. It's gonna go into tree and it's sort tree. And for now it's void and we'll decide if we want something else later on.
You
know,
might
it's
want to
cheap.
put it on top of the other one because the order you have it in the implementation.
Yeah, because we want sort tree to happen before balance tree. All right, we're back down here at the bottom and we're still like, all right, what are we gonna do? So now we can say node temp equals root. And we should definitely go if temp equals null pointer. And we need a vector person here. So we input the vector?
Yeah, input the vector from the balance tree.
Okay. That's fine. Let's do that. We'll just tell it to return arg, which is the current vector it's already with. Right, we don't need a CO. Okay. And since we're taking in the vector, I gotta go up and change my fucking prototype again. Oh my gosh. This is where I had in the first place. This is a vicious circle, right? All right, okay, so we're at a start. And left is we can use, no, wait, we're on the search tree now. So we could do something like the equivalent of this right here is if temp left. But we don't want to do that. Well, the problem, okay, so what's going on here is real quickly, something to think about. Like if we have a tree that goes like this, if we do while left and then while right, while left is going to stop here and be done. And then while right would go here and be done, and we wouldn't get to the end of the tree. Right? So that's the problem with iteratively. I mean, we could still do this, so it's just going to take more work. Say that again.
You can do a while, and then do another, like, while, you might need another. No, we can do it. Yeah, well noted, well temp is not, no point.
Wait, do I need that? Why is this? What? You're right.
Well, that only still take us to our original problem, but if we say, well, temp is not a no point, it'll keep going until temp reaches a no point. This goes one too close.
Okay, well, temp is not a no pointer.
And then if
You know what? I think this is much easier to read. Actually being verbose. The exclamation temp, this is the same thing as exclamation temp. But I think that's easier to read, at least in my head. So I'm going to type it that way. If you want to use exclamation temp, go knock yourself out. So while temp.getLeft is not null pointer, what are we going to do? We got to push back. So arg.pushback temp.getValue. Okay. Let me finish this and I'll comment it out. You tell me what you think is going to happen here. Go for it.
well, it's gonna check to see if temp is not a no point. Every time it goes left, it's just going to push back the next value. So if it's not a border, it pushes it back. Oh, but it doesn't matter. does it?
Right, because we're just populating the vector and then we'll
Oh,
sort the
no,
vector.
yeah,
That's what I was thinking.
yeah.
Let's not try to sort it as we're doing it. We have a comparator that sorts it. If we need to, we can.
I don't know why I was thinking like pushing it back from the very bottom of the tree.
And then we gotta go left. And then temp equals. Because I'm trying to make this lower. It's got to keep going, right? Right, it's got to iterate. So temp equals temp dot get left. And then do if temp dot get left or get right. Hold on. So this, I don't like the way this is going. Yeah, this is not, we can't go left and then go immediately, right? That's doing the very fucking thing I had on the paper. So I'm gonna comment that out for a second.
When we, when we're creating when we're balancing the tree, are we deleting the last tree and then rebuilding it?
I was thinking that we might pass a new tree, pointer to a new tree. Or we could just change the route and rebuild the tree. So we could destroy the tree all the way down to the root and rebuild the tree from the root so that the root pointer doesn't change.
If we do that, this works out really well, because all you have to do is iterate to the very last one and then delete it, but you know, also add it to the vector. Like set it equal to the pointer.
Right, so this is just, but what I have right now is only going down the left.
Yeah.
All right, so we need to make sure we got to get everything in the tree. We got to get everything in the vector, right?
Right.
Should I do an else if?
Else if works. I mean, if you really wanted to, you could just always use a ternary operator, but you know.
Get out. I'm not fucking doing that. I'm gonna fucking die in a fire. I don't know if this is gonna do it, but I think we can.
Would it make more sense to go from the very bottom of the tree going up and then delete it as we go? Or not delete it,
But we don't have a way of working backwards.
that's on the other one, the recursive trace tree.
But we gotta do it recursively then.
Um,
How are you gonna do that iteratively?
I did it with him.
Okay, tell me.
Okay.
So if you did it last night, it's on your fucking computer.
Not mine, it's on the other one, but I know it's, yeah, the. Oh, yeah, maybe that link this. No, I said it. I did it like just this Monday. We're doing it. I know it's more I did it more to delete the entire tree.
So we could do this. So with that and what you're saying, I'm gonna comment out the pushbacks right now. This while loop would get me to the end. Right? It'll get me to the end of somewhere.
Yeah. And then you would use.
So here, this is where I would do arg pushback of temp.
So you'll be at no. If you are push back, you have to have like one behind it. Or you could also.
So let's do one behind it. Node pointer current. We'll We'll say current equals temp. So we set current equal to temp each time. And then temp iterates. And so current is always the one that's the one right before the null. Right? So then we get out here, then we do arg dot pushback current dot get value. Current is another pointer. It's the one right before the temp. Because we're going to do current equals temp and then iterate temp. So temp always, we assign current to temp and then temp takes the next step. And if once it does that, if temp is like, it just stepped off the fucking cliff, then we know current was the last good spot. So that will do this. And then we could say delete current. Is that what you're saying?
Yeah,
But then we need a bigger while loop.
there's a problem with that too, and when you loop through, you don't set the very next one to loop it, so it'll hit it there. Change it to the next one.
Wait, what?
When you delete current, because current's the very, like, last node at the very end, there's no way to set the one before it, so that's connecting the node to the right one. So when you're trying to say, hey, get right at that left open, it'll say,
Okay, you're right.
so we have to like, not only just delete it, but we also have to reset it back to the.
So we need the one like pictorially. We're at D. So we push D. And then if I delete D, I need to just set D to a null pointer first, right? That's all I really need to do. Because the pointer hasn't gone away. The pointer never goes away. It's still pointing to the same thing. So we'll just say current equals null pointer.
It's not pointing at the thing, like, if you try it like this, it won't work. It doesn't connect it back to it thinks that you're talking about a completely different. Because now you're just rather than curve, it's just pointing at something.
But current is a pointer. So it's a pointer the whole time. This just deletes the data in current, doesn't it?
Yeah, it doesn't actually like
Current still pointing
No.
to this new spot. So the question is, if I do that pictorially, if I say push D, delete D, like I did, and then I say D equals null pointer, does C recognize right as null?
mm,
But D was a pointer itself, right?
yeah. Should be if that's what if we set the temp to.
Let's go look at how we set up the nodes left and right. These are, wait, back up to the top. Where am I doing? The nodes are set up, they are pointers, left and right are pointers. So that's what we're working with here. D is a pointer. I think it's worth a try. But now we got to go, okay, this needs to be in a greater loop that says while root isn't null.
instead of saying 10, you could say, if the left and the right is wrong, then check to see if the left, or if not, then check to see if the right. That could also work.
Wait, what?
Instead of getting temp all the way to the very last one, or like this one open, we can get temp to be towards the. We can get
So
temp to
we
be-
could just do if temp left is null pointer and temp right is null pointer. But then how do we decide which way to go?
Or we use another if statement. We keep the same if statements. At the end of the day. It just kind of avoids this.
Okay, so. First off, we're gonna set temp to root here each time. Because we're doing a greater while loop with the root. So you're saying if temp dot get left does not equal null and temp dot get right does not equal null. Then do the rest. Like that.
Now we can take off the other one.
Well, we got to iterate.
The iteration is happening to the. No, not the, just the while.
I know, it's just
Oh.
it's just balancing the way it reads.
Yeah. This is.
No, that while loop is necessary because this is only going to go left until it can stop going left. And it's going to go right until it can stop going right. But if there's another left after this, this needs to be while.
Yeah.
You know what? I'm undoing this. How about we put this fucking thing here? Right. So that gets us iterates through until there is no next, either direction. Then we push it back, we delete it, we say current, then we start back temp at root. And we go through it again. And it keeps going through it until it keeps going through it until it gets to the root, right?
It should. Couldn't we also do like an else statement that also would encapsulate if there was more? But let's say it goes through down both the left and the right, and it doesn't like it doesn't for whatever reason it's more than those two. Can we do an else statement? Because I feel like doing the extra while loop is a little extraneous outside of the other outside of our if statement, the giant one,
Well,
not
this
the
this while root makes sure it does all of it.
yeah.
This while root just gets us to the bottom. And
Okay.
then we push back the bottom value, delete it, and each time the tree keeps getting shorter and shorter and shorter.
Right. Because it's still within the other loop, the other one.
So let's look like I made this fake tree right here. We're gonna focus on this and see what happens, like walk through what's happening.
Okay.
So temp is here. And then current is here. And then if temp dot get left is not equal null pointer, it goes here, then we're over here. And then it goes again and we're over here. And now this one meets the whole left is null pointer and right is null pointer. So it goes on, it pushes back, it deletes it, and it makes this null. And it comes back up to the top.
Right.
And it follows it down and comes down to here and does the same thing here. Goes back to the top, does this one. Now it's here. This one's not. Yeah, now it's gonna go to the right and go left, do that one. Then it's gonna go right, right, do that one.
Mhm.
Then it's gonna go do that one. And when we get down to the end, now both left and right are null. And it doesn't grab roots value. So maybe we should just, after the whole loop's done, push back root. Does
Right.
that make sense?
Yeah.
Like, because we missed this one. That
Right.
one hasn't been captured.
Right. Because the other ones, the left and right are both null pointer, so it can't really do anything because
Right.
it's already met the condition. Okay.
It's met the conditions. It's not doing that one. So we're gonna do just arg pushback root. And this is the fucking sort tree, and we've entirely destroyed the entire fucking thing, which is not good because they were all pointers. So we just destroyed all of our fucking data. But now we've got our vector. Maybe we can delete root. What?
If you go back to your current equals roots, like, because,
Yeah, well, I could do delete current. Is that what you're saying?
no, I'm saying like, I don't think you can do that. Because, if you look at current where current is, if you have temp and current, right?
Uh-huh.
So temp is going to, the very second.
Oh, I think you're right.
Yeah.
Because this while loop gets us through that, but like, what about, like, I think this actually captured the last one. You're right. Because this gets skipped when that's not there.
Yeah.
It still pushes back. So maybe I should add current equals root up here also. Just to make sure. I want to be sure.
Yeah.
There's that's one fucking more line.
Yeah.
I think you're right. I think it was still there, but
Because first is one before the temp, right? So
right.
If it's one before the temp first, go at the very roots. Like it takes care of itself.
Either way. So this, I didn't need to take in a fucking, did we, this is actually, we're building our balance tree thing.
Yeah.
So I don't actually need to take in, I think we can do everything from here. We're just gonna rename it in a second. I don't want to change my code, so I'm just leaving it as arg. So let's make that a void, and we'll change the prototypes later on. And this is literally our balance fucking tree. So I'm gonna go down and delete balance tree down below because we're not doing that anymore. We're doing it now.
This is assuming that it does end up.
And I don't need to return arg anymore. I just return. All right, so we've now got our vector. Now we got to do the sort thing. So we do arg dot sort. It would, wait. How did that shit work? So I do sort, I don't call vector. This is just sort. Sort dot arg begin. Arg dot end, is it end? And then compare
Yeah.
beeps. So why doesn't it like that?
There's a
Sort is from the
string, right?
STD, isn't it?
STD. I
I
believe so.
did have using namespace STD, right? Yeah, I do.
Yeah, you do.
So why does it not like sort? Do I have parentheses? I do have parentheses. Oh my God, fucking go already. I know class is over in 2 minutes. We'll finish this on Monday. I want to make sure that line works before I close.
So, well, so I got it to work for me. What fixed it was adding the sorting library, include not sorting algorithm. My bad.
Include sort.
Yeah, include algorithm. It's a library. Yeah, there you go.
There we go. All right. We'll call that a pause for here and we'll finish this shit on Monday.
Cool. Take care.
Peace. All right. I will go paste this real quick. And announcements.
Take care, Jones.
Take care. You know what? I'm gonna change the fucking prototype up top before I do this. I just have binary search tree, balance tree. Let's come up here and make sure that's all we have up here. Yeah, we don't need that one anymore. We're doing void dot void. Yep. Control-C.
We did the same thing, didn't we? I think I might have sent the wrong one. We did this exact same thing, I swear. Excuse me. Because we're like, yeah, we could do this iteratively or recursively. You want to do it recursively or iteratively? And it's like, let's do
So you guys
iteratively.
balanced the tree while, like, in the
Did
2
you
hours
use
last
two
time?
times? We didn't balance the tree, but we our whole thing was like, okay, you know, this whole thing is done at runtime. Let's now figure out a way to delete the entire tree. And that's kind of what we did.
Oh, okay.
But it was the same exact process, like just going from the very bottom to the very top.
That's what inspired you to do it this way then. Okay.
Yeah. Find it. That was fun. I like made me think for a bit.
Right. And that's the point of this.
Yeah. Have to like really think hard. Yeah, I used 2 temps. He did too. Yeah, he used the current, the temp. Use current. Yeah, but it was the same thing. Let's see if I could. What is it called? Yeah, right there. We're like, do you want to keep practicing on it? Do you want to keep trying it? It's good practice for for your notes. It might come up on the test or whatever. And then
I'm not gonna make you develop a balance tree thing. Why would I? I know you're just gonna go to your lecture fucking notes and go from there,
probably.
right? That would be a waste of my fucking time. Does everyone want a free A? Here you go. Do the lecture notes.
Yeah.
Oh wow, this looks remarkably like what we did in class.
I did it a delete changing node, and that's what here's how I did it, I guess. And it works pretty well. It's like very similar here. Get left is multiplier. Oh, that isn't this.